Hello, my name is Ian Matthews. I'm a solutions engineer at AtScale, and welcome to the start of a new series of videos where I run through solutions to resolve commonly seen modeling problems. Today's problem is going to be currency conversion and how we can achieve this in AtScale. Any business that operates in many countries will inevitably need currency conversion to accurately report performance across different regions. Exchange rates can affect the profitability of international operations, and businesses will need to track these fluctuations to protect their margins. As such, currency conversion capability is essential when managing costs, setting accurate pricing, and making sound financial decisions in a global marketplace. From a technical standpoint, currency conversion represents a core modeling problem almost every global business will face in a universally applicable use case regardless of the business vertical. Today, we're going to run through a reference implementation of currency conversion using the AS Adventure dataset. It is portable and modular and can be quickly added to existing AS Adventure demos. It also has a dynamic cloud data warehouse connection, which can be quickly changed using the branches in the repository or using an environment file. The features of today's demo are a many-to-many currency conversion, allowing for rate period comparison and rate type comparison. So to get started, I'm going to go to Power BI so we can see what this looks like for the BI user. Power BI dashboard I'm showing now is based on and driven by an underlying semantic model which I've built in AtScale. Since it is connected to the AtScale semantic model, this dashboard is able to achieve a number of key reporting features. The first and most important of these features is in actually enabling currency conversion. In this particular instance, this is a many-to-many currency conversion. This allows the BI end user to consume any metrics in various input currencies present in the raw fact tables and report these in a particular currency of their choosing. So here you can see we have a base sales amount in a base currency, which are defined here as simple base currency metrics. And in our reporting currency metrics, we have the converted equivalent metric that is present in the currency metrics. And here we can select which currency we want to see that converted to. So right now it's currently set to euros. We can change it to Great British pounds, or we can change it to United States dollars. However, in typical business reporting needs, there may be a number of different rates used in currency conversions. These can range from spot rates, average rates, or even closing rates. Additionally, in specific reporting scenarios, the BI user may need to compare the effects of using the same exchange rate at different points in time, essentially comparing the same reporting metrics between historical, current, or forward exchange rate positions. In this example, we're using two different rates labeled actual and budgeted, and we will be comparing the effect of these rates from both current and historical rate positions. Now, the simplest way to achieve all of these requirements would be to create different sets of calculated measures as reporting currency metrics using the various rate types in the model. For example, we would have one set of reporting currency metrics with equivalent measures or metrics defined for the actual rate. And then we would have another one of these sets of calculated measures defined for the budgeted rate. Additionally, the modeler can also define different sets of calculated measures using the same rate type, statically partitioned by predefined time periods. So that would mean we would have another set of reporting currency metrics for actual rate with a rate position at 2006. We would then have the same thing, so one set of reporting currency metrics with actual rates with a rate position for 2007. And then this would also be repeated for any other rate types present in the analysis. And while this method is simple and easy to understand, depending on the reporting needs and input criteria, it can result in an overwhelming amount of semantic objects deployed to the BI endpoint. For example, if I wanted to compare 5 different sales KPIs converted using 2 different rate types at historic and current positions for the year 2007, I would need to create approximately 20 different calculated measures, roughly arranged as actual rates for the year 2007, actual rates for the year 2006, budgeted rates for the year 2007, and budgeted rates for the year 2006. Alternatively, the model can also be configured to allow the BI end user to dynamically select which rate type is used in the conversion based on dashboard, filter, or slicer criteria. Using this method means that the AtScale modeler only needs to define one set of calculated measures to represent the reporting currency metrics, allowing the BI user to decide which rate type is used on the fly. Moreover, different rate periods for any rate type can also be defined in AtScale using relative expressions, meaning that the rate position can be set respective to the selected date position in the dashboard and can also be configured using filters or slicers. So this is currently the way the dashboard is set up. So if I wanted to change the rate type on the fly, I can just select a different rate, and as you can see, I'm still using the same reporting sales amount metric, but I can switch between all of the various rate types present in the model. Additionally, as you can see, we have an actual rate position for the year 2007, and we have a prior year actual rate position as well. So this prior year actually represents 2006. So if I was to change the year to 2006, because this is the start of our data, you can see that we don't actually have a prior rate position for this point. But if I go to 2007, you can see the rate position for 2006 previously becomes the rate position for 2007. Now that I've selected the year position at 2007, and the same thing should occur for the year 2008. If this dynamic and relative conversion method is used, direct comparison between different rate types or different rate periods can be achieved using the calculation group functionality present in AtScale. This removes the need to create different sets of calculated measures for reporting requirements and significantly reduces the number of semantic objects exposed to the BI end user. So in this dashboard, we have two examples of calculation groups which enable this direct comparison, both between rate type and rate period. First, I'll go through the rate period comparison. Now, once again, we can still select which rate type we're using on the fly simply by picking which filter we want. And in this specific visual, what we have is the sale amount for the point in time of January 2007, both using rates for the point in time January 2007 and rates for the point in time January 2006. And these are represented by current year or prior year rates. Now I can change these to budgeted rates just so we can see the comparison between the two, and we can change the period as well that we want to look at. So if I was to go to 2006, because we have no prior year position for 2006, you can see that we don't actually have prior year rates for this point in time. But if I go to 2008, where we have both positions, you can see the visual will update accordingly. Next is to allow direct rate type comparison. This is fairly similar. We can select our year period. Here we don't have a slicer to compare between the two different rate types because we're actually directly comparing them in the visual. So we have actual rates for the point in time January 2008 and budgeted rates for the point in time January 2008. So we can see the effect that each rate type has on the overall sale amount. And these are simply defined as calculated groups within whichever dimension you choose. So for this specific instance, you can see I'm using this actual versus budgeted rate calculation group that I've defined. So here we are in the AtScale designer, and this is what the underlying model looks like. To achieve the currency conversion functionality I showed in the Power BI dashboard earlier, there are two extra components that need to be included to a basic semantic model. As you can see, this is a multi-fact model, and as such, an additional fact table containing rate information must be included and configured in the model. The next component that is required to properly set up the currency conversion functionality is the currency dimension that you can see here. This dimension is composed of three separate hierarchies. One to represent the base currencies in the sales fact table, the next to represent the reporting currencies we want to convert to, and the last is to represent the rate type which is selected in the currency conversions. In its raw form, the currency rate fact table would not be suitable for the functionality I showed in the Power BI dashboard earlier. It must undergo some transformation before it is fit for use in multi-currency conversions. And this can be achieved using our query dataset functionality. So this is what the raw fact table will look like. In it, we have a currency key, a date key, an average rate, and an end of day rate. In order to get this fit for use, a number of key transformation steps must occur. The first thing that needs to be done is to correctly determine which exchange rate values will be used in the conversion calculations. This is achieved by selecting and joining two instances of the currency rate fact table together on the date key position, with either instance respectively limited to the currencies present in the sales fact table, which we'll call our from table, and the currencies the user wants to report in, which we will call our to table, represented by the currency key values listed here. Once joined together, conversion rates between our base and reporting currencies can be determined by dividing the rates in the from table by the rates in our to table. This is completed for both rate types, average and end of day, which will become our actual on our budgeted rates. I've multiplied the budgeted rates by a factor of 1.1 just so we can see a noticeable difference between these rates for demonstration purposes. Once completed, joining keys for any dimensions that the user wants to report across must also be included to the fact table. Since we already have a currency key and a date key present in our raw fact table, we need to add a sales territory key and a product key to this fact table just so we can connect it to the rest of our dimensions in the model. Lastly, the fact table is unpivoted so that the exchange rates are grouped into a single column called rates with their respective headers, actual and budgeted rate, listed as rows in an adjacent column which I have called rate type. So here we can see what the fully prepared fact table should look like. As you can see, we have a product key, sales territory key, a currency key from, representing our base currencies, a currency key to, representing our reporting currencies, the date key, the rates between the different conversions, and the rate type, whether it's an actual rate or a budgeted rate. With the currency fact table prepared, the currency dimension can now be configured. This will allow the BI user to discriminate between the base currencies in the sales fact table, select between which reporting currency is shown in the converted metrics, and the rate type used in the conversions. To begin, the base currency must first be set up. This hierarchy is composed of a single level fed by a currency dimension table, which I've called dim currency base, and limited using a query dataset to just the currencies present in the sales fact table. So as you can see, we've picked the currency key for the key column and the currency alternate key, which is the currency representation as an abbreviation, as the value column. And that's all that goes into our base currency. Once our base currency hierarchy is set up, the reporting currency hierarchy can be configured. This hierarchy is also fed by a copy of the same currency dimension table. This time I've called it dim currency reporting. And just like the base currency table, this is also limited using a QDS, but just to include the currencies that we want to report in. However, to ensure that the currency conversion is accurate, a reporting date key must also be added to this hierarchy so that the model knows when to apply which rate when converting. This date key can be added from the currency fact dataset, which we created and prepared earlier, and using the currency to joining key to define a relationship between the two datasets, creating a snowflake dimension. So as you can see here, the second level in this hierarchy comes from our currency rate fact table. We're using our currency to key as a value and key column. And then below that, we also include the date key present from the same fact table as a key column and a value column. This will allow us to define a relationship between the two. I just hit apply. And we can see that we're joining the currency to key from our fact table to the currency key in our currency dimension table, which we limited earlier. It is important to note that only the reporting currency level of this hierarchy is exposed to the BI user. These two levels will be hidden and are only used to define relationships within the model. Lastly, the rate type hierarchy can be completed, and this is fed directly by the currency fact table, which we prepared earlier, and uses the rate type as key and value columns. And below this, we have an extra level, which uses our currency key to as a key and value column, but this will also be hidden as this only exists to form relationships back to the rest of the model. Once completed, I can simply connect my currency dimension and my fact table to the rest of my model based on all of the joining keys present. So our product key will go to our product dimension, our sales territory key goes to our geography dimension, and our date key goes to all of the various other date keys that we have listed in our dimensions. So our date key will join our date dimension on our two hierarchies, and our date key will also join our reporting date from the currency dimension. From here, our currency key from joins our base currency key, our currency to key joins our reporting currency, and also our rate type. And from our main sales fact table, our currency key will link to our base currency hierarchy, and our various date keys will join the reporting date keys. And with that, our model is now connected and we can start to prepare some metrics and convert them. Once the required currency fact table and currency dimension have been set up, I can begin creating my metrics and calculated measures. The first metric to define is the FX rate. As you can see, we're selecting the rate column from the fact currency rate conversion table that we created earlier. I'm setting an aggregation type to average. I'm formatting it so we can show 3 decimal places, and then I apply to set my settings. And with that, we have created an FX rate. Once I've defined my FX rate, I can then use this to create my reporting currency metrics using AtScale's calculated measure functionality. To do this, I can create a new calculated measure, and using any one of these base metrics I defined, I multiply it by this FX rate that I just created. So if I go into calculations, I can show an example of this. Here we have a reporting sales amount. This simply references the sale amount sum that I created in my base metrics, and I multiply that by the FX rate that I created earlier. I set my formatting to 2 decimal places, and with that, I have a reporting sales amount. It is important to note the rate type I am using in this calculation, actual or budgeted, can be defined by using the rate type hierarchy, simply just applying this using a slicer or a filter. If I want to hard code which rate is used in calculation, I can create a new calculated measure and using a static expression define the desired rate type I want. So here I have created another measure called actual FX rate, and in this I'm using the FX rate that I defined earlier, but this time I'm statically defining a position within the rate type hierarchy and setting it to the actual rate, which means this calculation will only show the FX rate values where the actual rate is present. I can then go ahead and repeat this for my budgeted rate using the exact same methodology. This time I've just defined the static position at budgeted rate. And I can also use static or relative expressions to define the rate period I want to compare, and then use this as a multiple in other calculations. So what this looks like is, you can see I have a measure here called PY actual FX rate. So what this stands for is prior year actual FX rate. And I've used a relative expression called parallel period. And what this does is it's going to take a look at the year position within my date hierarchy and offset that by 1. So essentially what that means is it's going to take a look at the date dimension. It's going to look at the year position I've selected. If that's 2007, it's going to move back 1 year. So it's going to become 2006. And it's going to select the actual FX rates I have for that position in time. And it's relative. So if I change my year to 2007, it's going to be 2006. If I change my year to 2008, the position is going to become 2007. Lastly, I can use calculation groups to directly compare rate types or rate periods. I can quickly show you what a calculation group looks like. To do that, I have to go into my dimensions. I've built my calculation group within my currency dimension. If I go into my code editor, you can see here I have a calculation group. For this calculation group, I've called actual versus budgeted, and what this does is it's going to take any measure that I've selected and it's going to apply a static position at the rate type to set for actual rates, and it's going to apply a dynamic position in my reporting currency hierarchy and then apply my FX rate as a multiple. So what that means is it's going to take the FX rates at the actual rate position and then multiply these by any measure I place in a table or visual, and it will still allow me to select between any of my reporting currencies. So whether that's euros, GBP, or USD, and again, something very similar for the budgeted rates. So what this will do is will allow me to compare my actual rates, or the effect of my actual rates on whichever metric I pick, versus the effects of my budgeted rates on whichever metric I pick. And that's a quick run through of the calculation groups.